your standard 6, you can see all these things. And I don't think you don't know what are these things. These are all magnets. And I don't think that you never seen a magnet or never played with a magnet. Whenever you go to some place, you buy some pictures and put it on your refrigerator or your iron almirah. This is a very common thing because you know there is a magnet. Even in our mobile, there is a tab, there is a magnet, it sticks there. So, magnet is but you have to know their properties. Here you can see 1 pair, 2 pair, 3 pair, 4 pairs of magnets, and they are attached to each other. See, when I am separating them, it clicks together. Why it clicks together? That means in these magnets there are written, this is north, this is south, this is south, this is north. That means north attracts south and south attracts north, so they are always together. And if I reverse it, then you see it goes away. But why it is north south? Why it is not AB? Why it is not alpha beta? Now we have a compass needle here, which you can see that the red part, it usually points some direction. I don't say which direction. It can be any direction. Okay, it is pointing this side. I just rotate it. Again it comes back to the same position. If I stop it, its oscillation, then again it is showing this part. Now in your house, if you have a magnetic needle or a compass like this, or a small compass like this, I think everybody has a compass in their house, and you will find these compasses also always point towards a path. Now you find out in your home which is your north direction and which is your south direction. And you will find surprisingly that red is pointing towards the north of your house, and the other side that can have any other color, that is always pointing the south of your house. That means from your home you can see the sun is rising, that is east. After that there is a north, then there is a west, then there is a south. So, as these pointers or the magnets are always pointing towards north and south, so the pointer, the end of the magnet which points towards the north is called a north-seeking pole or north pole, and which points toward the south, that is called south-seeking pole or south pole. And we make it very general, that north pole, south pole. That is why in this magnet only north and south, N and S is written. That you know, the one north pole, south pole. And if I take a north pole here, and if I try to go towards the compass, you see the red part is going away. That means north repels north. Similarly, if I take the south and take it towards the south, let me make it steady, and from this direction I go and see the south is going away. But if south is pointed towards the north, see the fan, it is pointing towards it. Whatever I go, this is always following it. It does not want to leave it. That means the opposite polarity, like the marriage is taken between a boy and girl. It is a very simple thing, all of us know. Similarly, the magnets south and north, they attract each other. And there is another very beautiful thing. These are called soft iron bar. This is attracted by this. But if I put another one, this does not attract. That means this is iron, but it is a different kind of iron. You don't have to know what kind of iron. But you cannot magnetize. Even there are balls. There are two bearing balls, which is used in the, you see, they are not attractive. That means this material, if they attract each other, then your cycle where there is bearing, in your car where there is bearing, in a truck where there is bearing, if they attract, they become slow. So, there are materials which cannot be magnetized, but it is strongly become a magnet when they are in presence of another magnet. Let us put it back. So, now you see, we have seen there is an attraction. Now I put north and south together. Now if I put it here, see, there is no attraction. I separate them, there is attraction, there is attraction. Then where the attraction is going? This is very, very important. That means physically we cannot see where it is there. South pole is attracting, north pole is attracting, but when north and south is attached together, see just the fun, north and south is attached, I am pressing. No, it is not attracting. Why not attracting? They should attract. They are north and south. That means north and south is not only attracting, they neutralizes each other. And that means it becomes a single magnet. This is south pole, this is north pole. This is attracting, this is also attracting. That means magnet attracts any iron, any part of that. Now if I take this as a single magnet and this is north pole, you see the north is repelled, again the north is repelled, north is repelled, south is repelled here, south is repelled. But if I put it here, you see south is strongly attracted to that. That means there is no fixed pole. You are very surprised now. When there is a magnet, there is always north and south. There is no meaning. Because these north and south, they can vary. Why they vary, we shall discuss in the class 7. But here you see, I put another magnet with it. Say the south pole, I put it here. Now again you see there is attraction, and there is no attraction anywhere here. So, poles are something imaginary which appears that the attraction is towards a particular point in the magnet, but when I take a single magnet, then if I touch at the center, there is no attraction because of the same reason. If you break it, then it will be two other magnets. Again break it, that will be two other. That means all the magnets are made by smaller, and how small we can go? You know, all material is made up by some atoms or molecules. So, molecules are the actual magnet. From this experiment, we can conclude that the molecules have the magnetic property and the total molecular effect gives a total molecular effect on a magnet. So, this is amazing. So, now I give a problem. You see, there are two bars. One of them is magnet, other is iron. How do you identify? You keep one of them and touch the other at the center. At the magnet, center is not having any attraction. You see there is no attraction. Then we know this is a magnet. This is a magnet. This is not a magnet. This is iron. And this is a magnet. Because magnet has north pole, south pole. See? North pole, south pole. This is attracting. This is attracting because this is an iron. But when I touch the center of the magnet, this magnet doesn't even attract. Please remember, there are four properties. One is magnet has north pole, south pole. They are north-seeking pole, south-seeking pole. So that is why a compass always points towards north and south. When north repels north, opposite poles attracts. But when two magnets are attached together, then pole vanishes. So we have two poles and the attraction, repulsion and the directive property. And there is the neutral region at the center. Now, obviously, when magnet is left out, there is every possibility they will go bad. So what we do, we have this kind of things which is made up of small, soft iron piece which cannot be magnetized. We put it here. We put it on the other side. Then what happens? They get neutralized. How do you know they get neutralized? I am putting this here. Now I am touching it. No attraction. But this is attracted. This is attracted. That means as soon as this piece is given there, this attraction is lost. That means now this has no magnetic property. Wherever you touch, there is no attraction or repulsion. So we always keep them with these bars, which is called keepers. Now another phenomenon I will show, then I will end with it. We have this magnetic needle, and we know that there are a lot of magnets here, so it has some trouble to point towards north. Anyway, now it is north. I want to change its polarity. How to change it? Now I take one of the magnet and see, this is a south pole. So south pole is attracting this north pole. Now what I do? I put it here and then just rub it. See what happened? This has gone to other side. Can you see any change? No change. Then where is the change? Just now I discussed, iron is made up of iron atoms, and atoms are molecules. When I am moving this magnet over it, the molecular magnet or atomic magnet, they are just rotating in their position. Then, can we change the magnetism of this by rubbing? No, because in this there are trillions of molecules, trillions of molecules. We cannot change its polarity by simple. But these are very thin piece of magnets, the compass, so we can change. So we have traveled through the amazing world of magnetism. Thank you very much.